Imagine, for a moment, a secret hidden at the edge of our solar system, a giant, distant planet that could change everything we thought we knew about our cosmic neighborhood. For centuries, we have looked up at the night sky, believing we had discovered all the major planets that orbit our sun. Pluto was once the ninth planet, but after its reclassification as a dwarf planet in 2006, we were left with just 8. Yet, in the back of some astronomers' minds, the nagging question persisted: is there another planet out there? One that has so far eluded our detection, hidden in the darkest, most remote corners of our solar system? The search for this mysterious world has captivated scientists and stargazers alike, and after years of research, we may finally be on the cusp of uncovering the truth. Welcome to the incredible, high-stakes quest for Planet 9. The idea of a ninth planet in the solar system isn't just a new concept, it's one that's been around for over a century. The discovery of Neptune in the 19th century was one of the earliest clues that there could be other undiscovered planets in the outer reaches of the solar system. Neptune's existence was predicted based on irregularities in the orbit of Uranus, which suggested that a more massive planet was tugging at its path. When astronomers turned their telescopes toward the predicted location, Neptune was found in 1846. Pluto's discovery in 1930, following a similar pattern, added another layer of intrigue to the solar system's puzzle. However, in 2006, Pluto was reclassified as a dwarf planet by the International Astronomical Union, which left us with 8 planets, at least, officially. But in 2016, everything began to change. Researchers discovered something that reignited the idea of Planet 9, an unusual concentration of objects beyond Neptune, in a region known as the Kuiper Belt. These objects, small, icy worlds, didn't behave the way they should according to the laws of gravity. Their orbits were strangely aligned, as though they were being influenced by something massive and distant, something we couldn't yet see. This discovery set off a new round of research, as scientists began to wonder whether these gravitational anomalies were the result of a large, undiscovered planet hiding far beyond Pluto. Planet 9, as it's now known, could be a massive world, with a mass around 6 times that of Earth. It's believed to be orbiting the Sun at a distance of about 400 to 800 astronomical units, AU, far beyond the orbit of Neptune and Pluto. For perspective, 1 AU is the average distance between Earth and the Sun, about 93 million miles. So, this planet would be located in a region so far from the Sun that it would be completely dark and nearly impossible to detect with current technology. Its orbit would take it around the Sun once every 7,400 years, which means it spends most of its time in the frozen outer reaches of the solar system, well beyond the reach of even our most powerful telescopes. If it exists, it's a planet unlike any we've ever encountered. But why has it been so hard to find? After all, we have the Hubble Space Telescope, the James Webb Space Telescope, and a number of powerful ground-based observatories at our disposal. The answer lies in the vast distances and the extreme darkness of the region we're looking at. Planet 9 would be located in an area of space so far from the Sun that its surface would be cold and nearly invisible to our current instruments. Even though Planet 9 could be a giant, its faint light would be difficult to pick up, making it nearly impossible to detect through traditional methods. And while objects in the Kuiper Belt may give us clues to the planet's existence, identifying these small, distant objects against the background of the Milky Way is like searching for a needle in a haystack. It wasn't until the discovery of Sedna in 2003 that scientists began to seriously consider the possibility of Planet 9. Sedna is a trans-Neptunian object, TNO, a member of the Kuiper Belt located far beyond Pluto. Sedna's orbit is not like that of most other TNOs, it's long and elliptical, taking it from about 76 Australian dollars from the Sun to a staggering 937 Australian dollars. This bizarre orbit suggested that something massive, something with a lot of gravity, might be influencing Sedna's path. Mike Brown, a professor of planetary astronomy at Caltech, and his team used computer simulations to investigate the potential causes of Sedna's unusual orbit. What they found was astonishing: the gravitational effects on Sedna could only be explained by the presence of a large planet, something like Planet 9. Brown's team wasn't the only one looking for answers. Other researchers have also been exploring the possibility of Planet 9, using different methods and technologies to track down the elusive planet. Some astronomers have turned to the study of the orbits of other TNOs, looking for patterns that could indicate the presence of a massive object lurking beyond the known planets. These gravitational anomalies are a key piece of the puzzle, as they suggest the presence of a planet with at least 10 times the mass of Earth, likely in an orbit that is tilted and inclined, different from that of the known planets. The search for Planet 9 has gained new momentum with the launch of advanced observatories and telescopes, particularly the Vera C. Rubin Observatory, which is set to begin its operations in the near future. This groundbreaking observatory, located in Chile, will be able to scan the sky faster and more efficiently than ever before, potentially uncovering previously unseen objects in the outer solar system. By rapidly mapping the sky, the Rubin Observatory will help scientists detect even the smallest changes in the position of distant objects, which could provide the breakthrough needed to finally spot Planet 9. While the James Webb Space Telescope has already made impressive contributions to our understanding of the universe, it's not ideally suited for detecting Planet 9 due to its limitations in the infrared range. The Vera Rubin Observatory, however, will be able to scan the entire sky repeatedly, making it the ideal tool for tracking down this elusive planet. Another technique that researchers are using to detect Planet 9 involves studying the effects of tidal heating. Tidal heating occurs when the gravitational forces of a large planet affect nearby moons or other objects, causing them to heat up. This process can make these objects easier to detect, as they emit more heat and light. By studying the potential tidal effects on the moons of distant planets, astronomers may be able to infer the location and characteristics of Planet 9. Similarly, scientists are also monitoring interstellar objects, asteroids and comets that pass through the solar system from other star systems. These objects may reveal subtle gravitational influences from Planet 9, giving us another clue as to its location. Despite the advances in technology, there is still no direct evidence for the existence of Planet 9. Some skeptics argue that the gravitational anomalies observed in the Kuiper Belt and among the TNOs could be explained by other factors, such as the combined effects of multiple smaller objects, or even the influence of dark matter. However, the consensus among most researchers is that Planet 9 remains the most likely explanation. The evidence is mounting, but the search continues. There's even an intriguing theory that challenges the very nature of Planet 9. Some scientists have suggested that what we are detecting might not be a planet at all, but rather a primordial black hole. Primordial black holes are theoretical objects that could have formed during the early universe, before stars and galaxies even existed. These black holes would be incredibly small, with a mass comparable to that of a planet, but their size would be minuscule, just a few centimeters in diameter. Unlike regular black holes, which form from the collapse of stars, primordial black holes would have formed from fluctuations in the density of matter during the Big Bang. If one of these tiny black holes exists at the edge of our solar system, its gravitational effects could explain the orbital anomalies we see in the Kuiper Belt. While the idea of a primordial black hole is fascinating, it's also unsettling. A black hole of this size would be virtually impossible to detect, as it wouldn't emit any light. It would be completely invisible to traditional telescopes. However, scientists are developing new methods to track down such objects, including the use of gravitational lensing. This occurs when the intense gravitational pull of an object distorts the light from stars behind it, creating a lensing effect that can be detected by astronomers. By observing these gravitational lensing events, researchers hope to catch a glimpse of a primordial black hole in the outer reaches of the solar system. It's clear that the search for Planet 9 is not only a thrilling scientific quest, but also a reminder of how much we still have to learn about our solar system. The mysteries of the cosmos are far from solved, and new discoveries are waiting just beyond the horizon. Whether Planet 9 is a massive, unseen planet, a primordial black hole, or something entirely different, the journey to find it will undoubtedly shape our understanding of the universe for years to come. As we continue to explore the farthest reaches of the solar system, we are reminded that there is still so much to discover. The search for Planet 9 is more than just an academic exercise, it's an adventure into the unknown, one that could redefine our place in the cosmos. And with each new technological breakthrough, we come one step closer to answering one of the greatest questions of our time: is there truly a ninth planet waiting to be discovered at the outer edge of our solar system? Only time will tell. But one thing is certain, the search for Planet 9 will continue to capture the imagination of astronomers and the public alike for years to come. As we peer deeper into the dark, distant regions of space, we are reminded that our knowledge of the universe is still evolving. What we thought we knew may only be the beginning of a much larger story. The possibility of Planet 9 reminds us that even in the age of advanced space telescopes and interplanetary exploration, there are still vast mysteries left to uncover. So, stay tuned, this search is just getting started, and who knows what exciting discoveries lie ahead.